In the autumn of 1884, a small steam vessel of approximately 30 tons displacement was running trials on the River Thames that left the officers of the Royal Navy's gunnery establishment at Shoeburyness in a condition approaching professional alarm. The vessel was HMS Rattlesnake, not a warship in any conventional sense, but a torpedo boat, one of a growing class of craft whose defining characteristic was the ability to carry self-propelled torpedoes and to deliver them against capital ships from close range at high speed. The Rattlesnake could make approximately 26 knots, which was faster than any battleship then in existence. She was armed with tubes for the Whitehead torpedo, a weapon that had, in the 15 years since its introduction into naval service, transformed the theoretical calculus of naval warfare in ways that the admiralties of every major naval power were still attempting to fully absorb. The specific alarm the Rattlesnake generated was not about the Rattlesnake herself. It was about what the Rattlesnake represented. She was one of a type. There were hundreds of her kind in service or under construction in the navies of France, Germany, Russia, and a dozen smaller powers. The Whitehead torpedo she carried had an effective range of several hundred meters and a warhead capable of tearing open the hull of any capital ship afloat. A battleship that cost £1 million and represented years of industrial effort could, in the calculations that torpedo boat advocates were performing in naval colleges across Europe, be sunk by a torpedo boat costing a few £1,000s. The arithmetic of that calculation was terrifying to any admiral responsible for a battleship fleet, and in 1884 the Royal Navy had more battleships than any other power, and therefore more to lose. The solution to this problem was not obvious. Battleships could not be made fast enough to outrun torpedo boats. Their guns were too large and slow-firing to track and engage small, fast targets at close range. Anti-torpedo nets, which could be deployed around an anchored vessel, were useless against a torpedo boat attacking a ship underway. The battleship, the most powerful warship in the world, had been made vulnerable to an attack it was fundamentally equipped to neither prevent nor adequately punish. What was needed was a ship fast enough to catch a torpedo boat, small and maneuverable enough to engage it effectively at close range, and armed with weapons suitable for destroying small, fast targets rather than the heavy guns designed to smash armor plate. What was needed, in the vocabulary that the Royal Navy would eventually adopt, was a torpedo boat destroyer. The man most directly responsible for translating this requirement into a physical ship was Admiral Sir John Arbuthnot Fisher, who at the time of the Rattlesnake's trials was not yet the dominant figure he would become in British naval policy, but who was already thinking about the torpedo boat problem with the systematic intensity that characterized his approach to all naval questions. Fisher understood, with a clarity that many of his contemporaries lacked, that the torpedo boat was not merely a weapon, but a symptom of a fundamental shift in the economics of naval power. The shift was that destructive capability at sea was becoming decoupled from the cost of the platform that carried it. A torpedo, once it left its tube, cost the same in lives and steel whether it had been launched from a 30-ton torpedo boat or a 3,000-ton cruiser. The platform mattered only insofar as it could get the torpedo close enough to its target to function. Fisher's response to this problem, developed through the late 1880s and eventually expressed in the design specifications he helped to develop for the first true destroyers, was to accept the torpedo boat's premise and turn it against itself. If small, fast, cheap ships were going to dominate naval warfare, then the answer was to build small, fast, cheap ships specifically designed to destroy other small, fast, cheap ships. The destroyer, in Fisher's conception, would be the torpedo boat's nemesis, fast enough to run one down, armed with quick-firing guns that could engage at close range without the slow reloading cycle of the heavy naval gun, and structurally sound enough to operate in the open sea conditions where torpedo boats would inevitably carry out their attacks. The first ships built to this specification were ordered in 1892 from a series of British shipbuilders, with Yarrow and Company, Thornycroft, and Laird brothers producing the leading designs. The contract specifications called for a minimum speed of 27 knots, which was faster than any torpedo boat then in service, and for an armament of quick-firing 12-pounder guns supplemented by torpedo tubes, giving the destroyer the ability to fight torpedo boats with gunfire and to attack larger warships with its own torpedoes if the opportunity presented itself. The resulting ships, the 27-knotters as they were informally known, displaced approximately 240 to 300 tons, measured approximately 58 meters in length, and required a crew of approximately 55 officers and men. They were not comfortable ships. The hull form required to achieve 27 knots in a vessel of that displacement was a long, narrow, shallow draft design that tracked reasonably well in smooth water and became a violent, unpredictable handful in the swells of the open ocean. The accommodation for the crew was minimal by any standard. The officers had small cabins aft that were perpetually wet in anything resembling rough weather, and the crew lived in the forward spaces, which were the wettest and most violently motion-affected part of the ship. The machinery required to drive the hull at contract speed was packed into a space that made maintenance a contortionist exercise, and the boilers, burning coal at the rates required to maintain high speed, generated heat in the engine room that made sustained high-speed operation a severe physical ordeal for the stokers. The 27-knotters established the type, but did not define it, because the process of operating these ships in fleet conditions immediately revealed both the specific capabilities they possessed and the specific limitations that the design had not adequately addressed. The most immediate operational problem was seakeeping. In the North Sea, where the Royal Navy spent most of its operational time, the weather conditions were frequently severe enough that the early destroyers could not maintain fleet speed or even operate safely, rolling violently and taking water over their bows at rates that their crews found alarming and their hulls found progressively destructive. Modifications to the bow form, to the height of the freeboard, and to the structural arrangement of the forward hull were introduced in successive classes through the 1890s, gradually improving the ship's ability to operate in the conditions they were actually likely to encounter. The armament evolved simultaneously. The original 12-pounder quick-firing guns were effective against torpedo boats at the ranges where torpedo boats operated, but the experience of using them revealed that the loading and aiming arrangements were not ideally suited for the rapid engagement of fast-moving targets. Lighter weapons, 6-pounders and 3-pounders, were tried and found inadequate against the increasing size and structural robustness of late 19th century torpedo boats. Heavier weapons, 4-inch guns, were eventually introduced in the early 20th century and became the standard main battery for destroyers through much of the First World War period. The torpedo armament also grew, from the single tubes of the earliest destroyers to multiple paired tubes, firing the increasingly capable 18-inch and eventually 21-inch torpedoes that gave destroyers a meaningful offensive capability against cruisers and even battleships. The naming conventions that the Royal Navy adopted for its early destroyers illustrated the ambiguity of the type's identity. The earliest destroyers had names suggestive of speed and aggression: Havoc, Hornet, Daring, Decoy. These were names in the tradition of small, fast naval craft, suggesting the type's descent from the torpedo boats it was designed to destroy. As the ships grew larger and more capable, the naming conventions shifted toward the more dignified conventions used for cruisers and battleships, and by the First World War, Royal Navy destroyers were being named for naval heroes, classical figures, and geographical features, reflecting the growing recognition that the destroyer had become something considerably more significant than an anti-torpedo boat specialist. The transition from specialized torpedo boat destroyer to general-purpose fleet vessel happened gradually through the first decade of the 20th century, and was more or less complete by the outbreak of the First World War in 1914. The transition was driven by two forces simultaneously: the torpedo boat threat that had justified the destroyer's creation was gradually diminishing as torpedo boat technology reached its practical limits and as the destroyer itself absorbed most of the torpedo boat's offensive mission, while the destroyer's own capabilities were expanding rapidly enough that it was finding utility in roles its original designers had not anticipated. The destroyer's speed and maneuverability made it useful as a fleet scout, the small, fast ship that could race ahead of the main fleet to investigate contacts reported by other scouts and to provide the fleet commander with current intelligence about the enemy's position and movements. Its torpedo armament gave it a meaningful offensive capability against surface targets, allowing it to be used in mass torpedo attacks against enemy capital ships in fleet engagements. Its quick-firing guns made it useful for the suppression of submarine periscopes and for the close-range engagement of any small surface craft threatening the fleet. And as the submarine became the dominant threat to the fleet in the early years of the First World War, the destroyer's speed and maneuverability made it the natural platform for the depth charge attacks that were the primary anti-submarine weapon of the period. The Battle of Jutland in May and June of 1916 illustrated the full range of the destroyer's evolved role in a fleet action. The British destroyers at Jutland performed fleet scouting, launched torpedo attacks on German capital ships and cruisers, screened their own capital ships from German torpedo attacks, engaged German destroyers in the confused fighting between the main battle lines, rescued survivors from sinking ships, and provided the fleet commander with communications links to outlying forces. The German destroyers performed equivalent functions on the other side of the battle. Between them, the destroyers of both fleets were the most versatile and the most continuously engaged vessels in the entire battle, present at every phase of the action and required to shift between different tactical functions with a speed that the capital ships, committed to their battle line positions, could not match. The losses among destroyers at Jutland were heavy. 8 British destroyers were sunk and numerous others damaged. 5 German destroyers were sunk. The casualties reflected both the destroyers' exposure to fire from multiple directions and the physical vulnerability of their thin-hulled, lightly armored construction to the hits they received. A destroyer hit by a heavy shell was a destroyer in serious difficulty because the damage that a 6-inch or 8-inch projectile caused to a vessel of 200 to 800 tons was catastrophic in a way that it was not to a 10,000-ton cruiser. The men who served in destroyers in fleet actions accepted this vulnerability as the cost of the speed and maneuverability that made their ships effective, which was a compact with mortality that destroyer sailors across every navy made and generally managed to live with. The submarine war in the Atlantic transformed the destroyer's role more completely than any single event in the First World War. When the German unrestricted submarine campaign of 1917 began sinking Allied merchant shipping at rates that threatened to knock Britain out of the war, the destroyer emerged as the primary tactical instrument of the Allied anti-submarine effort. Destroyers, with their speed to chase submarines on the surface, their sonar capability to detect them submerged, and their depth charge armament to attack them at depth, became the essential weapon of the convoy escort forces that the Allied navies assembled to protect their merchant shipping. The role was fundamentally different from the fleet scouting and torpedo attacking of the Jutland model, but the same physical characteristics that made the destroyer useful in fleet actions, its speed, its maneuverability, and its ability to carry a varied weapons load, made it equally useful for convoy escort work. By the end of the First World War, the destroyer had become so central to naval operations that every major naval power was building them at maximum practical rates, and the specifications of the type had evolved well beyond anything the designers of the 27 knotters could have recognized. The V&W class destroyers that the Royal Navy was commissioning in 1917 and 18 displaced approximately 1,100 to 1,300 tons, measured approximately 95 meters in length, and carried a main battery of 4 4-inch guns along with 2 sets of torpedo tubes. They made 35 knots. They were, in every quantitative dimension, 4 to 5 times the size of the original destroyers, with a proportional increase in firepower, seakeeping ability, and crew accommodation, though the accommodation was still regarded by destroyer sailors as inadequate for sustained operations in the North Atlantic. The interwar years produced a proliferation of destroyer designs across every major naval power that reflected both the lessons of the First World War and the specific tactical priorities of each navy. The Washington Naval Treaty of 1922 had imposed limits on battleship and cruiser construction, but had not directly restricted destroyer building, creating an incentive for naval powers to invest in destroyer capability as a way of maintaining tactical options within the treaty's numerical constraints. The result was a decade of competitive destroyer development in which each navy explored different arrangements of the fundamental trade-offs between speed, armament, range, and seakeeping that had defined destroyer design since the 1890s. The Japanese Fubuki-class destroyers, completed between 1928 and 1932, represented the most dramatic single step in destroyer development of the interwar period. The Fubuki class displaced approximately 2,090 tons and carried 6 5-inch guns in 3 twin enclosed turrets, 9 torpedo tubes in 3 triple mounts, and made 38 knots. They were, in firepower and in speed, substantially superior to any contemporary destroyer in any other navy, and blurred the boundary between the destroyer type and the light cruiser type in ways that forced the competing naval powers to revise their own destroyer programs upward in scale and capability. The American response to the Fubuki class and to the general escalation of destroyer capability was the development of a series of classes through the 1930s that culminated in the Gleaves and Fletcher classes that would bear the primary burden of American destroyer operations in the Second World War. The Fletcher class, which entered service in 1943 and of which 175 were eventually completed, became the definitive American destroyer of the war and one of the most successful destroyer designs in history. The Fletchers displaced approximately 2,500 tons fully loaded and measured approximately 114 meters in length. 4 General Electric or Westinghouse geared steam turbines drove them through 2 shafts to a maximum speed of 36.5 knots. Their armament consisted of 5 5-inch 38 caliber dual-purpose guns in enclosed mounts, a torpedo armament of 10 21-inch tubes in 2 quintuple mounts, and an anti-aircraft suite of 40mm and 20mm automatic weapons that expanded significantly as the war progressed and the air threat intensified. The dual-purpose nature of the Fletcher's 5-inch guns was a design decision of significant operational consequence. A gun capable of engaging both surface targets and aircraft allowed the same weapon to serve in multiple roles without the weight penalty of carrying separate gun systems for each purpose. The 5-inch 38 caliber gun was one of the most successful naval guns of the war, combining adequate caliber for surface action with a high rate of fire, approximately 15 rounds per minute from a trained crew, and a mount that could elevate to 85 degrees for anti-aircraft work. The combination gave the Fletcher class a versatility that earlier destroyers, with their separate arrangements for anti-surface and anti-aircraft armament, had not possessed. The operational record of the Fletcher class in the Pacific War illustrated the full scope of what the destroyer type had become by 1943. In a single deployment, a Fletcher might escort a carrier task force, providing anti-aircraft cover against Japanese air attacks, anti-submarine screening against Japanese submarine threats, and plane guard duty to rescue pilots who ditched after carrier operations. She might then be detached to support an amphibious landing, providing gunfire support against shore targets with her 5-inch guns, screening the landing ships against air and submarine attack, and ferrying supplies and personnel between the assault shipping and the beach. She might subsequently be assigned to a surface action group, using her torpedo armament in night attacks against Japanese surface forces, or her guns in the kind of close-range gunfights that characterized the naval battles of the Solomons campaign. The night surface actions of the Solomons, particularly the battles of Cape Esperance, Guadalcanal, Tassafaronga, and Kula Gulf in 1942 and 43 produced some of the most intense destroyer combat of the war, and validated the development of destroyer torpedo tactics in ways that were sometimes painful for the American side. At the Battle of Tassafaronga in November of 1942, a Japanese destroyer force of 8 ships under Rear Admiral Raizo Tanaka, executing a supply run to Guadalcanal, was intercepted by an American force of 4 cruisers and 6 destroyers. The Japanese destroyers, using their Long Lance Type 93 oxygen-powered torpedoes, which had a range of approximately 22 kilometers at 48 knots or 40 kilometers at 36 knots, damaged or sank 4 of the American cruisers, while losing only 1 of their own destroyers to gunfire. The engagement demonstrated both the extraordinary capability of the Japanese Long Lance torpedo and the degree to which American destroyer tactics at that stage of the war had not yet fully adapted to the specific conditions of night combat in restricted waters. The American destroyer sailors learned. The later battles in the Solomons saw the development of radar-directed torpedo attacks, improved communication between destroyers operating in coordinated groups, and a tactical aggressiveness in the use of the destroyer's torpedo armament that the earlier cruiser-centric approach to surface action had suppressed. By 1944, American destroyer commanders were fighting their ships with a confidence and a tactical sophistication that the Tassafaronga engagement had demonstrated was necessary. The European theater presented different destroyer requirements, shaped by the specific character of the war being fought there. In the Atlantic convoy battles, destroyers served primarily in the escort and anti-submarine role, working in coordination with corvettes, frigates, and escort carriers to protect the merchant shipping on which Britain's survival depended. The anti-submarine role demanded patience, sustained effort over long passages in terrible weather, and the kind of specific technical competence in sonar operation and depth charge attack that was different in character from the aggressive surface action of the Pacific. The destroyer sailors who spent the war in the North Atlantic convoy battles fought a war of attrition against an enemy they could rarely see and could only detect through instruments that were imprecise under the best of conditions and frequently degraded by weather and ocean conditions. The specific refinement of anti-submarine weapons and tactics through the Atlantic campaign produced the Hedgehog, a forward-throwing mortar that could launch a pattern of 24 contact-fused projectiles ahead of the attacking ship, while the sonar contact with the target was maintained, addressing the fundamental limitation of the stern-dropped depth charge, which required the attacking ship to pass over the target and then wait for the depth charges to sink to the target's depth, during which interval sonar contact was typically lost. The Hedgehog allowed attacks while maintaining contact, dramatically improving the effectiveness of anti-submarine operations. The destroyer and its close relatives, the destroyer escort and the frigate, were the primary platforms from which these attacks were conducted. The destroyer that emerged from the Second World War was, in every measurable dimension, a different creature from the torpedo boat destroyer of 1893. Where the 27-knotters had displaced 240 tons, the late-war destroyers of the major powers displaced between 2,000 and 3,000 tons. Where the original destroyers had carried 2 12-pounder guns and a single torpedo tube, the late-war destroyers carried multiple dual-purpose 5-inch guns, 10 or more torpedo tubes, depth charge equipment capable of delivering scores of charges in a single attack, and the early generations of radar and sonar that made them far more effective in night and poor visibility conditions than anything that had existed in the earlier period. The crews had grown from 55 to over 300. The post-war decades continued the evolution at a pace that the original destroyer designers could not have imagined. The guided missile, which entered naval service in the 1950s, gave the destroyer an anti-aircraft capability that far exceeded anything achievable with guns alone, and eventually an anti-ship capability of comparable range. The anti-submarine rocket, which extended the range of underwater weapons well beyond what depth charges and Hedgehogs could achieve, gave the destroyer the ability to engage submarines at ranges where the submarine had no effective counterattack. Nuclear propulsion, first applied to submarines, eventually reached surface combatants and removed the range limitations that had always constrained the operational endurance of conventionally powered destroyers. The contemporary destroyer, represented by ships such as the American Arleigh Burke class, would be essentially unrecognizable to a naval officer of 1895. The Arleigh Burke class displaces approximately 9,700 tons fully loaded, measures 155 meters in length, and is driven by 4 General Electric LM2500 gas turbine engines producing 100,000 shaft horsepower and a maximum speed of over 30 knots. She carries the Aegis Combat System, an integrated radar and weapons control arrangement that can simultaneously track and engage over 100 airborne targets. Her vertical launch system holds 96 cells that can be loaded with combinations of Tomahawk cruise missiles for land attack with ranges exceeding 1,500 kilometers, standard missiles for anti-aircraft and anti-ballistic missile defense, and ASROC anti-submarine rockets. She has no torpedo tubes in the traditional surface-to-surface sense, but carries helicopter facilities for 2 anti-submarine helicopters that extend her detection and attack range far beyond what any direct sensor on the ship itself could achieve. The Arleigh Burke class is not, in any meaningful tactical sense, the descendant of the torpedo boat destroyer of 1892 in the way that a modern rifle is the descendant of a flintlock musket. The ancestry is traceable, but the transformation is so complete that the connection is historical rather than functional. What connects the Havoc of 1893 to the Arleigh Burke of 2020 is not a continuous line of design evolution, but a continuous line of strategic and operational logic. The destroyer exists because the threat environment of naval warfare demanded a fast, versatile, multi-role surface combatant capable of operating in direct support of larger forces and independently as circumstances required. That requirement has remained constant even as the specific technologies used to address it have transformed completely. The number of destroyers in global naval service today reflects the endurance of this requirement. The United States Navy maintains approximately 68 Arleigh Burke class destroyers in active service. The navies of Japan, South Korea, China, India, and the major European naval powers all operate substantial destroyer forces. The aggregate global inventory of destroyer-type warships numbers in the hundreds. The torpedo boat destroyer, born of a specific tactical anxiety about a specific weapon in 1892, has become the most numerous class of major warship in the world, and it has held that position in various forms for over a century. The specific anxiety that created it, the threat of the torpedo boat delivering a cheap weapon against expensive capital ships, has never been entirely resolved. The modern equivalent of the torpedo boat, the fast attack craft armed with anti-ship missiles, presents something of the same calculus that the torpedo boat presented in 1884, a relatively cheap platform carrying a weapon capable of threatening ships that cost enormously more. The destroyers that patrol modern fleet formations are in part still doing what the 27-knotters were designed to do, screening the capital ships from smaller, faster threats carrying weapons disproportionate to the cost of their platform. The technology has changed beyond recognition. The underlying problem has remained constant. It is worth remembering, in considering the contemporary destroyer with its Aegis radar and its Tomahawk missiles and its anti-ballistic missile capability, that the entire type began with a specific and relatively modest tactical problem. The torpedo boat was too fast for battleships to catch, and something needed to be built to catch it. The something that was built to catch it grew over the course of a century, and through 2 world wars and the entire Cold War, into the most capable and most numerous class of major surface combatant in the history of naval warfare. HMS Havoc, the first torpedo boat destroyer, commissioned in 1893, was 240 tons and 58 meters long. The HMS Daring, commissioned in 2010, a Type 45 air defense destroyer, is 8,500 tons and 152 meters long. Both ships were called destroyers. The name is the only thing they clearly share. Everything else was earned, vessel class by vessel class, engagement by engagement, through a century of continuous adaptation to a threat environment that never stopped changing and that the destroyer, alone among major warship types, never stopped finding ways to meet.